Let's get that focused up a little better there. Alright, so elimination method for solving systems of equations. We'll call this 510. It's actually 5.9 and 5.10. When we're talking about a system, I'm talking about two lines. And there's three things that could happen. Either the two lines cross in one point, something like this perhaps, where they cross in one point where they share, or we have two lines that graph and it turns out that they're exactly the same line. So we have an infinite number of solutions. So this is one solution. This is an infinite number of solutions. Or the other option where there's no solution, where we graph a line and then we graph another line and we find that they never cross. What is it when two lines never cross? They're parallel, right. So this is no solution. Okay. Systems of equations are going to end in one of these three ways. Now, we did a problem on 5.8, where we talked about the two girls buying Physics Day ride tickets. Let's use that as an example. So I've got Mallory's ticket and Meg's ticket, and I'm going to say I've got Splash Mountain. Let's call that S. And centrifugal chamber, that we'll just call C for centrifugal. Now Mallory rode Splash Mountain 4 times. So Mallory rode 4 Splash Mountains and 2 centrifugal chambers, and she paid $39.50. Okay, that was Mallory's. Meg rode Splash Mountain a little less. She rode 3 times, but she rode the centrifugal chamber more. She ended up paying a little bit more, $42.75. Now, we want something to cancel. Isn't that sort of a common thing for us here in algebra, trying to cancel stuff? So we want to try to make something even but opposite. Now, I can either cancel the S's or I can cancel the C's. It doesn't really matter. One would be less work than the other. You say C? I would agree. Evan, you had a question earlier? Is that? Yes, absolutely, on the test. Plan on it. Okay, so what I'm going to do here is I'm going to take a look at these guys, and I'm going to see that I can make the C's the same but opposite pretty easily if I multiply the top number by -2. Okay, the top equation. Now, I can't just multiply one thing. I got to multiply everything in that equation. So this is going to change to -8s, -4c, and -2 times $39.50, that's going to be a -$79, or just -79. Now the bottom, I don't have any changes, but I want to rewrite that. Once I have something the same but opposite, which would be my C's, I'm going to take the sum of these. So what's -8 plus 3? -5s, good. These guys cancel. If something doesn't cancel, you've made a mistake. It's not going to work out for you. And negative 79 and 4275, what is that? 3625? Would be negative 3625. So then if I divide both sides by negative 5, I get the price that both paid for the splash ride, which is $7.25. I was able to cancel one so that I can just focus on one type. Now, once I know a variable, once I know a value of a variable, what can I do with that? Plug it in, that's right. And we can plug this S in either here or here. It doesn't matter. I'm going to plug it in here, I think, just because it's closer. So I'm going to substitute, we call that substitution. So I eliminated a variable. Now I'm going to substitute a variable in. So this is going to be 3 times 725 plus 4c equals 4275. Now, this guy here is 2175. And now I'm going to subtract the 2175 from both sides. And I'm going to get 4c equals 21. Right, 21 bucks. And so the last step would be to divide by 4. That should be $3.50. So these are both in terms of money. And usually we're talking about a point on a graph, so my S was my X, so it's going to be 7.25 and 350 are my X, essentially the X and the Y on the graph. Yeah. Where did I get 350 from? You're correct and I'm wrong. Thinking about another problem that we have later on today. I'm jumping ahead of myself. What can I say? I'm human. I'm sorry. I'm sorry. How can you forgive me? Can you? There we go. You're right. 525. All right. Let's look at least a couple more. Unfortunately, this can take some space when I'm working it out for notes. So is everybody with me? Can I swap to the next page? Let's see. Jimmy's still got a moment there. This is when I start thinking of the Jeopardy tune. Na 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 na, right? Da, da, na, 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 na. Okay. All right. Let's look at an example 2. If you're watching this from third period, you're right. I'm doing the examples in a little bit different order, maybe even some different problems. 3x minus 4y equals 13. Y equals negative 3x minus 7. Now, we have a problem with this that I want you to be aware of. The problem is that our x's and y's aren't in the same order in both equations. In fact, if I was given this problem, I wouldn't do elimination at all. I would do substitution. I'd take this value for y and I'd plug it in and go on like we did a little while ago with substitution. But since we're talking about elimination, what we want to do is we want to get everything in the same order. So what I would do is either solve both of them for y's, or I think I'd just move this x back over. How about if I just add 3x here? And then this is going to be the same. This is going to be 3x minus 4y equals 13. And this guy is going to be 3x plus y equals negative 7. And now we have the x's and the y's in the same order. So now I need something to cancel. Will anything cancel naturally? Is anything there that'll just... Yeah? What? What cancels? But I need one of them to be opposite. They need to have opposite signs. So one of these guys needs to switch to negative. How about the bottom ones, right? So that would be multiplying everything through by a negative 1. What's that going to do to our signs? It's just going to change the signs. So how about if I change all the signs, negative, negative, positive. Now I can take the sum of these. I'm adding them up. So 3x minus 3x is 0, right? That cancels. We need something to cancel. The x's cancel. Negative 4y minus y would be negative 5y. And 13 plus 7? 20, yep. Yep, 20. Now we just divide by negative 5 and we get our y value. Negative 4, yeah? Excuse me. Feels like Monday still. Now that I have a y value, are you with me? Are you sure?
Barely.
Okay, keep writing. Now that I have a y value, I can plug this negative 4 in here or here. It doesn't matter. Somebody pick for me. Into the negative, which one? The first one, this one? Okay. So 3x minus 4. I'm going to sub in negative 4 for the y equals 13. Combine these guys, that's going to be 16. Now I'm going to subtract 16 from both sides. I'm going to get 3x equals negative 3. Negative 1, right. Divide by 3 and we get negative 1. So what I have is I've got an x and a y value, which means that it's a point where the two lines are equal, because these are both lines of an equation. This is where they cross. They have an intersection. Okay, let's look at one more. Let's look at a hard one. You're going to be saying, like, what do you mean? That wasn't hard enough? They don't really get all that much harder. 4x plus 2y equals 8. 5x plus 3y equals 9. This is along the lines of about as hard as they get. Now, you could have harder numbers to deal with, but the idea is about as hard as it gets. So what we want to do here is we want to pick either the x's or the y's to cancel. I'm not going to pick. One of you guys picks. It doesn't matter to me. Y? Okay, y it is. So we want to get the y's to be the same. So it's kind of like finding a common denominator. What's a number that both 2 and 3 will divide into? 6. Or 12. 12 works, but 6 works as well. So what I want to do is I want to turn these both into 6y, but I want one of them to be negative. So let's start with the top here, and let's start with the positive. What would I have to multiply everything through to turn this into 6y? Well, let's go with the positive first. 3, right? Now, on the bottom, what would I have to multiply to turn this into negative 6y? Negative 2, right? So I have to multiply everything here by 3, so that's going to become 12x plus 6y equals 24. Okay? And this one's going to be minus 10x minus 6y negative 18. Okay, so we have the y's are the same. These cancel. And we're going to get, so this is where I take my sum, I add them up. That's going to be 2x equals 6. Good. So now we're almost done with x. X equals 3, right?
Couldn't you also multiply the top by 1.5?
Yeah, you could, and it would kind of work out for you, but it's better to keep whole numbers. If you want to get tricky and multiply by decimals or fractions, you're more than welcome to, Reagan. I encourage that sort of challenge, but I don't know that I would teach it that way.
1.5 is easy.
Not if that's 4 or 5x. If that was 5x, it wouldn't be all that easy. You'd be left with decimals, right? So you kind of lucked into one where it does work evenly pretty well. Okay, so now that I have an x value, I'm going to take and I'm going to plug that in either here or here. Denise, which one? This one? Okay. We're going to put it into the first. So this is my substitution. 4 times 3 plus 2y equals 8. 12 plus 2y equals 8. I'm going to subtract the 12. 2y equals negative 4. And now I divide by 2. Y does equal negative 2. So my point where the two lines cross, 3, negative 2. What I've found in the past is that students who get the hang of the elimination like it far better than the substitution or any other method. And I tend to agree. If I can eliminate, I choose that firstly. There are times where substitution makes more sense. And example 2, I think substitution would have been a better choice right out of the get-go. But I like them both. If I had to choose one, I would say elimination. Right. So let's look at some problems.